Hi, welcome back. Today we are going to look after TCP/IP protocol. TCP/IP stands for Transmission Control Protocol and Internet Protocol. It is specifically designed as a model to offer highly reliable and end-to-end byte stream over an unreliable network. Let's jump into that session now. Protocol is nothing but a set of rules and procedures. Anything you call it as a standard definition for two parties, that's called a protocol. A abstraction layer between internet applications and the routing and switching fabric, that's a protocol. The next thing what we are going to look after is a transmission control protocol and internet protocol. Both of them, what is that each protocol stands for and whether one can live with other or not. Okay, let's jump into the transmission control protocol. TCP is responsible for data delivery once that IP address has been found. What does it mean is the TCP will be giving that message delivery from one place to other place. That's the mode of the transfer. The next thing is how data exchanged over internet. This is about what is the medium of data exchange. Is that through wire or digital? That's the medium what we are talking about. The next thing is about how applications can create channels of communication across the network. So if there are two different applications in one specific communication, how that each channel or each medium has expanding that communication channels. How a message is assembled into smaller packets before they are transmitted over the internet and reassembled in the same order at the destination address. The next thing is internet protocol. IP is a part of that obtains the address to which data is sent. How to address and route each packet to make sure it reaches the right destination. Example, let's take example. IP is a part of obtains the address which is data is sent. And how that address, just while ago we have seen this. For instance, there is a mail needs to be sent from one place to other place. We need to write down the to address and from address and then we'll give it to the postmaster. The postmaster, it decides whether that address can be reachable through which medium. Is that through by rail or bus or through aeroplane? That's the medium of transport what we are talking about. For TCP/IP, as we discussed in the example, the postman on the mail delivery address the mode of transfer. Without that, the intended message will not be delivered to the other party. So, without TCP and IP together, there is no meaning. There's nothing can be achieved. So we always call TCP and IP together. Our purpose is met with TCP and IP when it's together. This suite is the most common used protocol suite in networking world. Internet was built using this protocol suite. It is based on 4-layer model that is similar to the OSA layer. However, the OSA layer is a logical reference model, but this 4 layers of TCP/IP is a physical model. Protocol suite is being defined for internet world. It supports many routing protocols. It can be used to establish connection between two computers. Let's take a look at the 4 layers. The 4 layers are application layer, transport layer, internet layer, and physical layer. Application layer stands for it provides access to network resources. Application layer, what does it stands for is it allow access to internet resources, network resources. Without this application layer, say example, I'm clicking something on my desktop computer as a Skype, I'm sending a message to one of my friend. From that application, it intercepts the protocol on the application layer, then convert that message into that communicable medium or communicable message. The transport layer, the next layer comes to place when to provide reliable process to process message delivery and error delivery. For example, this is the layer. In application layer, we have a sample protocol such as SMTP, HTTP, and POP3. SMTP is a simple mail transfer protocol, and HTTP we knew that that's a web protocol, and then POP3, this is for the Outlook mails. It's responsible for maintaining end-to-end communication across the network. This is the place where it makes sure that my information is being really reached my target or not. There are two types of protocols we can see, TCP and UDP. TCP is the message reliable protocol, but we cannot guarantee the speed. However, when it comes to UDP, The message delivery may not be priority for the UDP, but speed of the delivery is a priority for the UDP. For example, the TCP, if I'm sending some message, if that has to be assembled on the target place, then that message has to be without losing anything. I need to send it across. However, when it comes to UDP, for example, there is some telecast is happening for the radio or TV. Even one of the frame or packet data has been missed out, still we can convey that message in the display of the TV or radio. Internet layer deals with packets and connects independent networks to transport of packets across the network boundaries. To move packets from source to destination to provide internetworking. This is called the internet layer. So however, the internet layer is a second layer of the TCP model. It's known as a network layer. The main work of this layer is to send packets from any network and any computer till they reach the destination irrespective of route they take. Internet layer offers the functional and procedural method for transferring variable length data sequences from one node to another with the help of various networks. Message delivery at the network layer does not give any guarantee to be reliable network layer protocol. Example for this layer is our IP and ICMP protocol. ICMP stands for Internet Control Message Protocol, which is subset of the IP network IP suite. The last one is the network component that interconnects nodes or hosts in the network. Examples: Ethernet and ARP. ARP stands for Address Resolution Protocol. In the coming sessions, we can look after each protocol and how that protocol works and why we prefer one another. In going forward, we can look after each protocol individually and look at the workings of each protocol. How this TCP/IP works? Let's take a look at, for example, from the address to someone sending address by giving the mail from to and from, and sender, what he does is the sender sends the message, then it goes to the router. Say example, this is my computer, the sender is my desktop or my computer. Is once I say send, say example, I'm sending some email or a Skype message, what happens is it sends to the router and router takes a different route. So every message can take a different route and it sends that shortest path it's possible. For example, in our case, it can be anything, even shorter or longer, but it depends on how that each packet behaves and how the router routing the request to reach the destination address. The sender and from the to and from is this, to is the sender's IP address. Sorry, from is the sender's IP address and to is the receiver's IP address. So that packet is received on the receiver side and it's arranged in the same order so that the receiver can read that message. With this example, the step 1 TCP protocol breaks data into packets, and second, the IP protocol, packets travel from router to router over the internet according to IP protocol rules. And the last step is reassemble the packets into original message, again which is the TCP. If you look at that, if you want to send one message from one place to another place without TCP and IP participation, it's not possible. The last slide of our session is comparison between the OSI layer and TCP/IP layer. The OSI layer is a logical reference model and TCP layer is a physical model. The TCP and IP model is the internet is being built on, which was invented much even before OSI layer was founded. There are three layers together: application layer, presentation layer, session layer together, and it's been given as application layer in the TCP/IP model. Transport layer, still we call it as a transport layer, and network layer can be called as the internet or network layer in TCP/IP model. Data link layer and physical layer together we call it as a network model. Thank you. TCP and IP OSI model, we have looked at the comparison, and hopefully this clarifies the reasons for the TCP/IP layer, 4-layer protocol, and what it does and how it works. Thanks for watching. Tech and Sasi. Subscribe my videos. Thank you.